Okay, so welcome. And what we're going to do now is, in this video, we're going to solve this a different way. Okay, we're going to use hyperbolic trig functions. Okay, so let me show you. So we know that hyperbolic sine is defined for all values of x. So the whole, so the domain is all real numbers. So we can use hyperbolic sine. Oops. Yeah, that's right. Oh, that's not right. Hold on. So we can use hyperbolic sine for our substitution. Okay? Why? Because it's defined for all real numbers. And so we could use this substitution for x. We also know that the derivative of hyperbolic sine is hyperbolic cosine. So then we know that cosh, or cosine h, is equal to dx, d theta. But we also have an identity, right? So we know that yeah. Right? Oh, I'm sorry. This is minus. So we know that we have these facts. Okay, so we're going to use these to solve. So I'm going to substitute in here and then we're going to use these. Okay, so now if I substitute in, dx is going to give me this. And then I get 1 over 1 plus theta. Well, we know that's true. So now we can replace this with, gotta have an integral. The integral of okay. Right? So just take the square root of the square here, and I get cosh over cosh. Now, since cosh is positive, Okay, cosh is positive for all values of x. So that means we can drop the absolute values. And this becomes the integral of 1 d theta, which equals theta plus c. Now, what's theta? Well, if this is equal to x, then theta is equal to the inverse hyperbolic sine of x. So this is going to be equal to now, notice that this is very different than what we got using tangent, okay? But to see that these are the same solution, that these give the same solution, let's do this. Let's say y is equal to this, which then gives us that, right? So now, what's the definition of hyperbolic sine? Okay, so this is something, again, this is we didn't cover this, but again, just to show you what I mean. Okay, so hyperbolic sine involves exponential, natural exponentials. So this is going to equal, so let me write it this way. Okay, so that's the definition of hyperbolic sine. Now what I'm going to do is I'm going to multiply both sides by 2e to the y. Okay, and so I'm going to simplify this, and the reason I'm doing this is because I'm trying to get this into a form that I can go ahead and take the natural log of both sides and solve for y differently, okay, and get a different expression, okay? So, what do I get? So if I simplify this, what do I get? I get e to the 2y minus 1 equals 2 e to the y x, right? Okay, so now let me rearrange this. And so what do I get? I get e to the 2y minus 2x e to the y minus 1 equals 0. Right? And so now I've got this quadratic of e to the 2y, right? I've got this quadratic in terms of e to the y, right? So this is a quadratic function of e to the y, right? Because it's got this form of ax squared plus bx plus c, right? So I can solve this for e to the y using the quadratic formula, right? So let's see what this looks like. So this, oh, you know what, I'm going to do it up here. So now I get, well, this is going to be my equation. So what do I get? I get e to the y is equal to my a is 1, my b is negative 2x, and my c is negative 1, right? Okay. So now I'm just gonna, so again, here's my a. My a is 1, my b is negative 2x, and my c is negative 1. Okay, so what I'm going to do is I'm going to plug this into the quadratic formula. So e to the y equals negative b, which is 2x, plus or minus the square root of b squared, which gives me 4x squared, minus 4 times AC, which is negative 1, which gives me a plus. Okay? Over 2b, or excuse me, 2a, which is just going to give me 2. And so if I simplify this, I get e to the y is equal to 2x plus or minus the square root of 4 times the square root of x plus 1, lo and behold, look at that, over 2. Well, the square root of 4 is 2. And so the 2's are going to cancel, right? Because this is going to be 2x over 2 plus or minus 2 times the square root of x squared plus 1 over 2. So the 2's are going to cancel. And so look at this, I get x plus or minus the square root of x squared plus 1. Now, I've got a plus or minus here. So if I look at the minus, well, from the previous video, you should know why this is going to be negative for all values of x. So this one is not the one we want. So that means we want x plus x squared plus 1. Okay? Now, this is e to the y, right? Don't forget, e to the y is equal to this. So now, to find y, we just take the natural log of both sides, and this gives us that y is equal to the natural log of the not the absolute value, we don't have absolute value. So x plus x squared plus 1. Now, all we have to do is realize that, remember from the previous video, this is positive for all values of x. So that means we can go ahead and put the absolute value in and we're okay. So let's put the absolute values in there. And we're done. We just showed that y is equal to the natural log of x plus the square root of x squared plus 1 is exactly the same as as the inverse hyperbolic sine of x. And we're done. So they do have the exact same solutions. Okay, just a different way of expressing it. Okay, have a great day.